everyone. This is an introduction to graphing rational functions by hand. So here's one problem here that's a little different. And since this is an introduction, we're going to do it by hand. We're not using parent functions or anything like that. We're going to look at the branches of the graph and as they approach asymptotes. And we're going to find our vertical asymptote, our horizontal asymptote, and then we're just going to find some points to help us finish the graph without a calculator. So for the vertical asymptote, this is the easiest one. It merely is where x, the denominator, cannot equal 0 because you can't divide by 0. And that would occur at x equals -1 and x equals 1. Therefore, we have two vertical asymptotes. Vertical asymptotes are x equals +1 and -1. I'll just put plus and minus 1. That's a 1. All right. The horizontal is a little harder. It's more conceptual. So what it means is as our value of x increases, as it gets larger, what does my y get closer to? So, for example, and if I write this as y equals, just for now, I'm going to write as 3 over x squared minus 1, because that's what that is. If I put a large value in, say I plug in 10, and if I do that, I'm going to get 3, 10 squared is 100, minus 1 is 99. Well, that's really close to 0. We want an integer value, if we can do that. So let's plug in an even bigger number. So if I plug in, say, 1,000, you have 1,000 squared. And who cares about really that -1? But that's just going to be 3, and then you have 1, 2, 3, 1, 2, 3. Minus 1. Well, that's 3 over 999,999. That's very close to 0. So the bigger the number is, the closer y gets to 0. So that means your horizontal asymptote is y equals 0. So that's the concept. So now let's graph it by using points. I'm going to graph my vertical asymptotes, which were at x equals -1 and x equals 1. We got this thing divided into 3s, so we're probably going to have 3 branches on this. So let's look and see. So I'm going to start on the right-hand side here. This is your 1. So I'm going to plug in 2 and see what's going on this side. If I plug in 2, and I'd really rather write this as 3 divided by x squared minus 1. So if I plug in 2, I'm going to get 2 squared minus 1, and that's going to be 3. So you can get 3 divided by 3 is 1. So this goes to 1. If I plug in 1 1/2, it's going to go up in this area. If I plug in, let me try to plug in a number. We don't have to use a calculator. If I plug in, let's say, 5, so that's 3, 4, 5. If I plug in 5, I'm going to get 3 divided by 24, which is 1/8. So it gets really close. So your graph looks something like this on this side. It gets closer and closer to 0 as x gets closer and closer to a large number. Now, let's see what's going on in between -1 and 1. So there's your 0. Let's just plug in 0. If I plug in 0, I get -3, which is down here. If I plug in, was this 1? So if I plug in 1/2, I'm going to get 3, and then 1/2. So that's 1/4 minus 1. So that's going to be 3. Oh, this is going to be negative. So that's minus 3/4. Minus 3/4. So it's a minus 4. So it's going to be here. And you do the same thing for negative 1 1/2, you'll get this. So that means this is going to open down. Remember, when you're dividing these, you just multiply that. So that would be negative 12 divided by 3, which gives you that. And all of these are pretty symmetric. So there's that piece. Now let's plug in a value over here. So let's plug in negative 2. And once you do this, you'll be able to tell. If you plug in negative 2, you're going to get y equals, I'll just do this, x squared minus 1. So that's going to equal negative 2 squared is 4. That's going to equal 1 again. So basically what you're getting is this reflection of this one over here. So just mark it over here and make it a reflection. So this one has 3 branches. Well, it has all these branches here. This is going off and getting closer and closer to x equals 1. This was x equals 1. This was x equals negative 1. And this side here is getting closer and closer to y equals 0. And the same thing for this one. It's just getting closer and closer to your vertical asymptotes. And this one is in the framework of these two. And that's it. Thank you. Have a nice day. Bye-bye.